So we watched the School Yourself arc video. And it told us that a minor arc is less than 180 degrees. So if you have an arc that has 2 letters in it, you know it's the little one, the little half of the circle. And then the major arc has 3 points. So I would name this green one arc A, C, D, with a little baby arc on top of it. Okay. So if I had this diagram as on your paper, let's name this pink arc. Yeah, you fill it out. What would be the arc's name? GR or RG or RG. Either one. You know, it's the smaller one because it only has 2 letters. When we do measure of arc, we're going to do a little in and then the arc name. Think back to earlier in the year when we had like measure of angle E. What were we looking for if we had that symbol? E? Yeah, so this whole thing. Measure of angle E. In what? Degrees. It would be in degrees, right? So when we measure an arc, it's still going to be degrees. So put that on your notes. Give yourself a reminder. The measure of an arc is in degrees. And what's the measure of arc RG? 160 degrees. Then arc length is the distance. So if I had like a measuring tape or a string to measure, it would be the distance from R around the circle to G. The distance of that pink line is 8 inches. Now let's look at the arc going the opposite way around the circle. So that green arc. RAG, RTG, GTR, GAR. Any of those names would work. So I'm going to go with GAR. As long as it starts with G and ends with R, or starts with R and ends with G, either one of those works. Could be rag. And what's the measure of arc RAG or GAR? How do you get 200? Right, 360 minus the minor arc measure. And I did your question. Someone asked, can we do 4 letters? So could it be RATG? That is no, you cannot. It's only 3 letters. Okay. And then our distance, we can just kind of estimate. It doesn't have to be exact. It's not labeled on here. Let's say 10. Let's do like 12 inches. This little corollary basically sets up this proportion for us. So it says the ratio of the length of a given arc of a circumference. So that's like this little space right here. So the ratio of the green to the whole entire circumference, which is 2 pi r, put that C, is equal to the measure of that arc over 360. We're basically doing part of a whole is equal to part of a whole. Now get out your blue sheet and try to find this formula, arc length of AB. On our blue sheet, it gives us our formula in this form. So the arc length is equal to the measure over 360 times 2 pi r.
Oh God, where does it tell me that? Oh, it's on the side.
Okay, so let's try to find the arc length of AB on our little picture. On your notes too.
Oh my
So
God.
I'm going to take the arc length formula. So the arc length
It starts with
is equal to What's the measure of arc AB? 88 degrees.
How do we know that?
Because the measure is the same as the central angle that you have. The angle that makes up the arc is the arc measure. You're using it. If we're looking for, it's always going to give you two of the pieces of information. So right now we're just plugging the stuff we know from this circle into the arc length formula. If we needed to know the distance from one point on the circle, and it's times the circumference, or 2 pi r. So 2 pi, and our radius is 2 meters. I'm going to bring out my calculator. I'm going to type it in just like this, because it's 2 pi times the radius, which is 2. You could simplify that to 4 pi. It's the same thing. So I'm going to do it exactly how it looks. So I'm going to do alpha y equals, to get a fraction, it's 88 divided by 360. Make sure you arrow over so you get out of the fraction. And then times 2 pi 2. Say 3.1. So our arc length is equal to 3.1 meters. So for P, so far I've just copied this formula down in here in the blue. So let's plug in what we already know. Do we know the arc length?
Yes.
Yes, it's 38.
So 38
And then
is equal to, do we know the measure of Rx?
No.
No, that's what we're trying to find. Times 2 pi, and what's the radius?
it's 12.3.
12.3, it tells us. So see if you can simplify. So once we've kind of set up our equation with what we know, we have 38. We're going to multiply both sides by 360. Get rid of that fraction. 38 times 360. Oh my goodness.
I got
164.
Keep that in your calculator. Our next step is to divide. So just hit divide, brings out that answer. To both sides.
You times it by 38. Multiply it by 38. You get the other side.
And I'm going to multiply it by 2 pi 12.3. That all in parentheses.
That's what I got. That's what I got.
Wait,
I actually got 176.
wait, you divided it by
That's exactly
all
what I
that. Now we have sectors. So before we were looking at arc lengths, like that green. Now a sector is the area of a circle that's included by 2 radii of a circle and their intercepted arc. So basically it's just saying you take 2 radius and it's the piece of pizza right in the middle.
So an arc is a piece of the what? An arc is a piece of the
Crust, which is like
crust, which is the
outside.
circumference. A sector is like the
pizza.
pizza. It's a piece of the
Whole thing.
The area. Yeah. So arc is circumferency. Sector is area.
So we have almost the same proportion as what was for the arc length, but this time we're doing sector area. So we want to know how much pizza are we going to get if I type. Not necessarily, because it's not always the same. It's not exactly a third of the circle. It could be less or more. So it's taking the area of that piece of pizza over the whole area of the circle. So pi r squared. and then that's equal to the measure of that arc. Remember, that's going to be a degree measure. I have something degrees over the whole entire 360 degrees. Copy that over. And then to get area of the sector by itself, we're just going to take this pi r squared and move it over.
Dividing the left side by something is the same thing as multiplying the other side by something, right? So we just multiply that over, and this is the formula that you'll see on your cheat sheet. So right now, find sector area on your blue cheat sheet.
Okay. So we're trying to find the sector area formed by angle RQS. So it's already shaded in for us. So our area is equal to the measure of RS. What's the measure of RS? 63 degrees divided by 360 times the area of circle Q. So pi times R, which is 5, squared. There we go. And we can even just type it in our calculator, just like this. So you
How do you put in a fraction?
Alpha.
Alpha y equals.
63 divided by 360, arrow over to get outside of the fraction, times pi 5 squared. High five. High five. That's a place. Which is about 13.7 what? 13.75 units squared.
Radius.
So as our blade moves on an arc, it's covering a portion of that windshield, and we want to know how many square inches is the area of that space that's being covered by the windshield as it slides back and forth. Now we know the length of the wiper blade, our radius, is 14.75, and the measure of the central angle is 132 degrees. And since we want to find the number of square inches that make up that contained area, we're going to use the sector area formula. Now for our formula, we need two things. We need the value of theta and the length of the radius. We know that theta is 132 degrees, and we know that the radius is 14.75 inches. All we have to do now is substitute those values into the equation and solve. So I replace theta with 132, r squared with 14.75 squared, and then I just have to evaluate the rest of the formula, which should leave us with a sector area of approximately 250.6 square inches, the surface area of that sector on the windshield. So our second example takes us out to a track and field event. Jordan and Tyler are teammates and partners on a relay race, and they're running on a curved track with a radius of 25
Make sure you
meters.
know how to do this.
We also know that
Explain it for
Jordan's
you.
location is 153 degrees away from Tyler's. Now what we want to find is the distance on the track. Let's go ahead and visualize that curved racetrack. And since Tyler and Jordan are in a relay race, they're spread apart. They're on different locations on the track, and they have to meet each other and pass off a baton. So let's call Jordan's location J and Tyler's location T. Now we already know that the radius of the curved portion of the track is 25 meters long. We also know that Jordan's location on the track is 153 degrees away from Tyler. Now it's important to visualize that Jordan's going to have to run on a curved path along the track until he reaches Tyler and hands off the relay to him. So we don't want linear distance, we want curved distance. Therefore, we're going to use the arc length formula to find the length of arc JT. Now for the arc length formula, again here we just need two pieces of information. We need the measure of theta, the central angle, which we know is 153, and we need the length of the radius, which we know is just 25. So again, just substitute those values into the formula, between the two runners to be 6